In our intro video, I covered the basic styles of ramps you're likely to build: perpendicular, diagonal, and parallel. But in this video, I'm actually not going to tell you how to build them. I'm going to tell you how to build them to ADA standards. So how do you do that? Well, every ramp is a little different, but memorizing just 3 things will help ensure success or guide you towards it, whatever ramp you're building, wherever you're building it. Check your calibrated levels early, often, and always. Memorize 2 numbers, 8.3% and 2.0%. Got a question? Don't wait, ask. In the first video, you might have noticed one tool appearing again and again, the level. That's because you simply can't build a ramp to ADA standards without using a level you calibrate every day. If you want your ramp to pass anyway. Measure twice, pour once, we say. Then, those 2 numbers. In the first video, we showed you the 2 basic components of every ramp. Parts that take you up and down, and parts that are basically flat, where folks can rest and turn. 8.3% and 2.0% are all about those 2 parts. 8.3% is about the ramps, the parts that go up and down. If you build a ramp whose slope is greater than 8.3%, your ramp will fail, guaranteed. That's why our design max is 7.2% for all of our ramps, so there's some construction tolerance. 2.0% is about the other parts, the landing areas, which are supposed to be level enough to rest on, but with enough slope where water doesn't pool. If you build a landing area with a slope greater than 2%, your work will fail, guaranteed. That's why we specify a 1.5% design max for all the landing areas we design, again, to give you some construction tolerance. And last, but definitely not least, communication. Do you have a question about the design specs? Notice something unusual about the location where you're building? Something missing or confusing in the plans? Ask us about it. Seriously. Yeah, we know asking questions can be hard, but we can't tell you how many ramps have been saved because someone noticed something and asked about it. Have a question? Don't wait. Ask. So again, check calibrated levels early, often, and always. Memorize 2 numbers, 8.3% and 2.0%. And got a question? Don't wait. Ask. Okay, let's go through a typical build to show you how these work and why they're so important. After excavation, the site is clean with nothing in your way. A perfect time to grab the plans and walk the site. Do those plans match what you're seeing? Anything on the site that the plans don't fully address? Anything that doesn't make sense in the plans themselves? If so, pro tip, don't wait. Talk to us. Because now's the time to bring up any questions or issues before gravel and concrete make them expensive to solve. And we're here to help. Believe me, we've tackled every kind of problem. Make use of us. And about those plans, you'll see a lot of numbers packed in there. But understanding them is pretty simple once you know a few things. The large numbers are elevations. So for example, 117.18 means this point in the finished ramp needs to be at exactly 117.18 feet elevation. This one needs to end up at 116.87 feet, and so on. But here's the real secret. Thanks to these numbers, a little math also tells you the height difference between these points. 117.18 minus 116.87 equals 0.31 of a foot, or about 3 3/4 inches. The top of this ramp needs to be 3 3/4 inches higher than the bottom of the ramp. 2 other tips about reading plans. TC means top of curb. You'll also see TFC, which means top face of curb, but it's the same thing. So that number means the top of the curb needs to end up at 117.15. Underneath that number, you'll often see G, which means gutter. So here, your final gutter elevation should be 116.65. And yeah, you guessed it. If the curb is 117.15 and the gutter is 116.65, the difference between them is the height of the curb. Half a foot, 0.5, or 6 inches. Math may not always be fun, but it sure makes everything clearer. Questions answered. Use your plans to start spraying out the panels so everyone knows what's where. Then, staking at panel intersections. Double check those placements frequently, since stakes can and do shift or tilt. And use a bubble level to ensure every stake is absolutely vertical. Next, working from established reference levels, mark stakes and insert nails to hold string at each panel intersection. These stakes and strings will be your guides for the forms and the pour. If they're off, your pour will be too. Like I said, measure twice, pour once. In fact, you'll do yourself a huge favor by buying a construction laser level to help in this phase. Using one is your best chance to match the project's design specs and avoid failures. Why? A construction laser level gives you a rock-solid elevation reference you can measure off anywhere on your site, instantly. Here's how it works. You remember the elevation numbers on the plans we showed you a minute ago? And you remember how you can easily subtract a smaller number from a bigger number to get the height difference between them. Well, a construction laser level gives you a number, the same number, anywhere on your site, to measure off of to nail the elevations on the plan. That's because it starts from a rock-solid reference. One point on or near your site that surveyors have certified to the 100th of a foot. First, set up your laser level somewhere stable with line of sight to everywhere on the site. Once it's up and running, find that surveyor's reference, sometimes called a mag nail, sometimes a hub. Spray painted next to it will be the certified elevation of that exact point. This one says it's at 121.09. Now, place your Lenker rod on the reference point and see where the laser hits it. Let's say that it's at 4.26. So, what's the elevation of your laser? You guessed it, it's the hub point plus the height where the laser hits the rod. 121.09 plus 426 equals 125.35, your golden benchmark. So now, because that laser is perfectly level, you can figure out the exact elevation of every point on your plan set. Just do some simple math. For example, need to hit 119.25 curb height in one area? Well, how far is that from the laser's height? 125.35 minus 119.25 equals 6.1. So right there, your curb will be 6.1 feet down from the laser. There are more tricks and tips to using a construction laser level we don't have time to get into here. But you can see that if you set a construction laser level correctly at the site reference point, you'll have precise levels anywhere on your site, instantly. Get one. As you're finalizing your levels, you'll want to begin compacting aggregate. The smartest strategy is to compact 2 to 4 inches at a time. Make sure not to overfill. So now we've got string lines in place confirming heights and measurements to ensure straight form lines. It's also a good idea to spray form lines for visual confirmation. As you build the forms, make sure to double check your levels constantly. Note the use of multiple levels to ensure both top and baseline alignments, and to ensure your slopes match the design elevations. On your left, the form for the curb as we move along the gutter. Note multiple stakes, all reinforced and double-checked to ensure the concrete load won't push them around. Get the curves smooth in the forms, and your pour will follow. On the form for the flares, Mark the target concrete level so when you pour, you have a visual reference. Now we're ready for the pour. Before the truck arrives, double-checking all measurements and slopes will save your bacon if anything's shifted overnight. Make sure you have an inspector present. Start working the concrete immediately. Repeated little adjustments versus fewer large and panicked ones is the secret to getting the concrete where you want it. And of course, start checking your levels as soon as possible and constantly from then on. Remember that flare line on the form? That extra touch paid off. As the concrete begins to set, waves of finishing begin. Smoothing and leveling, cutting joints, and finally, brooming. Note the attention to detail, always backed up by double-checking levels, because until concrete fully sets, it's a moving target. Placing the tactile dome panel requires special precision. First, scrape out enough concrete to compensate for the bulk of the panel. Then, smooth it out to ensure an even, level platform for the panel. Dig a little concrete out from under the form to help confirm the panel is perfectly flush with the surface. Here, your level confirms you're within spec and ensures the panel is perfectly flush with the concrete around it. Finishing might seem like window dressing, but it's your last chance to ensure against humps, bumps, lumps, sags, lips, or ridges greater than 1/4 inch that can cause compliance failures. Now, the concrete's hardened enough to pull stakes, but not so hard you can't fill the holes and complete the finish. And the forms come off. Look how clean that curve is. Now that's real artistry. Don't forget to ensure a smooth transition between curb and gutter. So remember, check your calibrated levels early, often, and always. Memorize 2 numbers, 8.3% and 2.0%. And got a question? Don't wait. Ask. Thanks for watching.